if you have a question like this and you're given the map below, the first thing you do, you measure here to here to know the distance. But in this case, you already been given that it is 6 here. But in an exam condition, you will not be given. So you are the one to measure it up yourself to know what the distance is. And now the question is asking us to reduce it to half the original size. The original size here is 6 by 4 cm. So half of 6 is going to be 3, and half of 4 is going to be 2. But to know how to locate the various features on the map, the gridding will help you do that. And by gridding, you first of all, having known the distance, you think of how you are going to divide this distance from here to here equally. And if this is 6 centimeters, to divide this equally, that means you will measure 3 cm each. You measure from here, probably from here to here is 3, and from here to here is 3, from here to here is 3, and from here to here is 3. So you have succeeded in dividing this side of the map into 3 equal halves. By that, you are gridding the map. And the breadth of the map here is 4 cm. And to divide 4 cm equally will be 2 each. So that means you measure 2 cm and mark out the point, and that you have done your gridding. You now extend it down, Having done this, you have gridded the map, meaning you have concluded section or step 2 of the steps involved in reducing or enlarging a map. But in this case, we are talking about map reduction. Having gridded the map, the next thing you do is you measure out half of 6 is what? Is 3. Now, don't be confused. This is the original map we are given. And we are the one that have gridded the map. And this grid is to help us transfer the features of this map into the new map that we are expected to reduce. So we are going to draw out a new map entirely. But the new map will be the reduced map. Now, half of 6 is 3. So you measure out 3 centimeters. Let's say that's 3 centimeters. And half of 4 is 2. So you measure out 2 centimeters. This is now 3 centimeters, and this is now 2 centimeters. And you do the same gridding to the new map, just like you gridded this one. So how are you going to divide this? If from here to here is 3 cm. In this case, 1 cm will give us equal division. So if we divide this, say this is from here to here is 1, here to here is 1, here to here is 3. And in this case, 1 cm also will give us equal division of this map. So let's say here to here is once here. You extend so if you count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, that means we have equal number of squares. The next step there is transfer the features from the original map to the reduced map accordingly as they appear on the map. What we mean by accordingly is you don't see a river running from here to here, and then when you want to transfer your feature from the old map to the new map, you now bring it running from here to here. That is wrong. That is the essence of gridding the map, so that with a grid, you will know which grid or which square the feature falls in, so that you'll be able to transfer it accordingly to the new map. So from what we have done so far, you can see obviously that the first feature here, which is the major road, is running from the second grid. You may decide to level the grids A, B, C, D, E, and F. You do the same thing here. A, B, C, D, E, and F. So, you see that the feature here is running from grid B. From this area of grid B, cuts across A up to D. So you follow it just the way it appears on the original map. You do same to the old or to the new map. You look at it, follow it accordingly. Okay. And note that it has been reduced. That means the size of the road also is reduced. Everything happening to the old map, the reduction effect which affect the new map or the old map also affect the features. That is that for the road. Now let's look at feature the query which falls on this grid C or square C. Obviously everything is within this grid. So you come over here and represent this feature just the way it is represented on the original map. But in this case, it has been reduced. So you expect the feature to look smaller than it is on the original map. That's the query. Now let's look at transfer the river from the old to the new map. You come to grid F, just follow it the way it is flowing. Up to grid E, and that's that. And finally, let's look at the vegetation. Now, take note of this particular tree that appears almost in between D and F. So you represent it just that same way. By so doing, you have successfully transferred your features from the original or old map to the new map, which has been reduced. Now, having done that, what you do is you now change the scale, take care of the scale. Note also that when you reduce a map, the scale changes. Now, if the scale of this map originally was 1:50,000, 1:50,000, the scale of the new map will not remain the same, will not be 1:50,000. So now, to get the scale of the new map, what you do is you multiply the old scale by the number of times you are requested to reduce the map. And from the question, we are asked to reduce the map half of the original size. So what you do is you divide or you multiply this by half. 1:50,000 multiplied by half. That will give you the new scale of the reduced map. And if you do this arithmetic calculations, you will have that the scale of the map will become 1:100,000. Therefore, we have 1:100,000 as the new scale of the map. Now, notice something, that while reducing the map, the representative fraction becomes bigger. It was 50,000, 1:50 here, and here it has become 1:100,000. So take note of that concept, that while reducing the map, the representative fraction